Stretching across the top of our planet like a verdant green crown, the Boreal Forest is Earth's largest forested biome. Home to moose, wolf, caribou, bear, and countless other species, this vast wilderness of spruce, fir, and pine holds more than a third of the world's forests and stores massive amounts of carbon, helping regulate our global climate. But this forested frontier is changing, and for years, scientists could only theorize about how. The Earth system is complex and dynamic, with feedback mechanisms that can drive positive and negative outcomes.
For decades, there have been ecological and climatological models that have theoretically predicted that the boreal forest, given climate change, should be moving north.
Previous studies provided hints, regional evidence, indirect measurements, but the boreal forest changes slowly, very slowly. To truly see what's happening, you'd need to watch the entire forest continuously for decades. So how could researchers possibly test this hypothesis at such a massive scale? Enter Landsat, NASA's longest-running Earth observation program. For the first time, scientists could analyze the entire boreal forest using the complete Landsat archive.
This study is the first and only study to comprehensively study the entire boreal forest from 1984 to 2020 using 224,000 Landsat images, mapping the tree cover in every pixel, 30-meter resolution, and then testing whether or not the boreal forest is moving north.
The research team, led by NASA and TerraPulse, calibrated Landsat satellite data using NASA's airborne field campaign LiDAR measurements and commercial images to create the most accurate map of boreal tree cover ever produced. They then tracked changes in every 30-meter pixel, an area about the size of a baseball diamond, across 36 years in the entire circumboreal region. The scope is staggering, analyzing the complete northern forest belt spanning Alaska, Canada, Scandinavia, and Russia.
The study's groundbreaking just in its sheer scope. The longest record, the highest resolution. The data were calibrated using LiDAR. Just every resource was thrown at this study to get the final definitive answer.
And the answer is clear. The boreal forest is shifting north. Between 1985 and 2020, the forest's median latitude moved northward by 0.43 degrees, roughly 60 kilometers. The forest also expanded by 844,000 square kilometers, a 12% increase, and it's getting denser, with tree cover increasing across most latitudes.
What we found is that the forest is getting denser across most latitudes. At the very southern edge of the boreal forest, there are a couple slices, latitudinal slices, where the net change of the forest is being lost. But the pattern of those losses is pretty consistent over time, and those changes within latitude across time aren't really changing as much as the growth.
The boreal forest's northward shift affects everything, from managing fuel load fire risk to industrial operations of timber, oil, and mining, extracting resources across North America and Eurasia. It changes wildlife habitats and the forest's ability to store carbon. The expanding forest is also getting younger, with fast-growing trees that could sequester additional carbon if allowed to mature, a potential positive outcome of warming and climate benefit. Yet other factors could drive negative outcomes, which requires additional studies.
The boreal forest is poised for a major transition. Permafrost is thawing. The forest composition is changing. All of these things can lead to an abrupt shift in the ecosystem from one type to a completely different type. With shorter term or less calibrated data, we can see abrupt changes. But with the long-term, highly calibrated Landsat data, we can see the slow changes. It makes it sort of a canary in the coal mine. It's a slow canary, but if we have the long-term, high-resolution, highly calibrated data, which Landsat gives us, then we can listen to its song.
This research represents the most comprehensive analysis of boreal forest change ever conducted, made possible by decades of Landsat observations and NASA's commitment to understanding our changing planet.